Hello everyone! This is the 6th video in my build log series for my virtual reality motorized shoe. If you're new here, I'm trying to build a motorized shoe to be used in virtual reality games so that you can walk as much as you want in the virtual world, in the game world, but stay in the same spot in the real world. If you'd like to see my progress so far, leading up to this point, then you can watch my prior videos. I'll leave links to those in the description. But in this video, I fixed the problems that you guys saw in the last video. Those two problems being that the binding is so flexible that as you bring your foot forward, the shoe pivots out at a weird angle, which I'll show here in a minute, and the shoe would also rock. So the first problem, you'll see here, see how the shoe pivots out, turns out, and here we go again. Turns out that's because the binding is flexible here at the back. So I fixed that first. All I needed to do was to make the back rigid. Here's the updated binding. This part back here is now rigid, and then this part too. It screws into the flexible part of the binding, so this is all flexible still, and you can see these three screws here. And then this part is still flexible too, and it screws in, as you can see. And the other small thing I did was I 3D printed a spacer here, because there was a problem where this whole binding would slide slightly along this rod as I used it, and it would also introduce a little bit of play because it could angle a little bit. So this prevents that. And now if I lift it up and then I turn it, you can see there's no flex. Before, the whole binding would flex a little bit, but now there's no flex. So here's my foot strapped into the new binding with the rigid back. Let's test it out. So I lift my foot and go forward. You can see the binding didn't flex, the shoe didn't pivot out. Okay. So one problem down and another to go. The other problem, as you probably noticed just now, is that the shoe rocks back and forth because when your foot is in the air, there is no weight on that side of the shoe. All the weight is on the other side, so it tilts the other way. But as you move forward, it just rocks back and forth. So to solve that, I decided to use a ball transfer. And I used a ball transfer that I 3D printed. I designed this a while ago. I have an article on my website where I talk about a bunch of different ball transfer designs that I tried out. And if you guys are interested, I will leave a link to this article in the description. But I 3D printed the one that I found worked best. How it works is you put BBs inside of the ball transfer, and then you have the main ball. This is a ball that is 1/2 inch in diameter, just a steel sphere. And then you take this cap back here, put it on top, and it holds the ball in place. And then you put screws through these 4 holes to hold everything together. So I took that and I screwed it into the opposite side of the shoe, opposite from where your foot goes, so that it would prevent the rocking. And what I actually found was that this ball transfer did not touch the ground. It was a little bit too short. So what I ended up doing was printing a few spacers, and I would just put these on the back of the ball transfer to make the ball transfer a little bit taller, and just keep stacking these until it was at the perfect height. And I found that stacking 2 of them here made this the perfect height. Then I went to testing it. Here's my foot strapped in once again. Ball transfer on the opposite side. So bring my foot forward, the shoe no longer rocks, so it appears that the ball transfer has fixed the problem. That's it for progress I made on the VR shoe this last week. Next up, I'm going to hook a battery up to the shoe and see how long the battery will last before it needs to be recharged. I ordered a battery. It'll be here tomorrow, and it's 5 amp hours, 12 volts. I'm hoping that battery will last a good while, maybe over an hour, maybe 2 hours. So the way I'm going to test that is I'm going to just hook it up to the shoe and run the shoe for about 10 minutes like you normally would, and then see how much it drains the battery, and then calculate from there how long it would take to drain the battery. Okay, and we'll see from those test results if batteries are a good option for powering the shoe, if they can hold enough charge to last for an over an hour session or a 2-hour gaming session. Okay, and I'll let you guys know that I probably won't make a whole lot of progress next week because I am traveling. I am not at home for Thanksgiving, and I am going to be traveling for work, so I won't be home all of next week. Won't be able to really work on the shoe a whole lot. I might fiddle around with the 3D models to try to make the shoe look cooler. I might also update the design to maybe accommodate different types of ball transfers. Not the ball transfer that I showed in this video, but the other 4 that are under the foot. They're loud, if you didn't notice, and I would like to use another kind of ball transfer. So one that probably uses a nylon ball, so a plastic ball instead of a steel ball. I think those will be much quieter. But I need to update the design to accommodate for those, and then I'll test that out in a future video. That's it for what I did this week, and what I'm going to do in the future. So, one last thing I did last week. I posted on Imgur about the shoe. I made a post that just goes into high-level details about how the shoe works and my progress that I've made on it so far. It did surprisingly well. It got 127,000 views. The comments and upvotes were overwhelmingly positive, and it made it to the front page of Imgur. So if you want to check that post out, I'll leave a link to it in the description. But that is it for this video. If you liked it, please leave a like. If you disliked it, you can dislike it and tell me what I can do better, please. And if you want to see more, subscribe to this channel. So, until next time, thanks.